Okay, for this problem, we're asked to determine the points at which the function f to the right has discontinuities. For each point, state the conditions in the continuity checklist that are violated. Okay, so let's start from the left and move to the right on this. Okay, so as we start from the left and move to the right, the graph starts at x equals 1. So would this be considered a discontinuity in the graph? Now you could probably make the argument that it discontinues. It doesn't go any further to the left here. But as far as it being a discontinuity in terms of the definition of discontinuity, it's really not a discontinuity. It's a endpoint. And the only way that an endpoint could be a discontinuity is if there's actually a hole in the graph there. So we look at our checklist down here and we say, is f of a defined? So is f of 1 defined? So we go here and we look at the graph, and there is a solid, let's make that is a solid dot there, not an open dot. So that means, yes, it is defined. F of 1 is equal to 4. So it is defined. Then the next one says, does a limit exist? Okay, well, you may have learned from earlier that in order for the limit to exist, the limit from the left and the limit from the right have to be the same. But in this case, since this is an endpoint, we don't have to look at the limit as we approach from the left side. Okay, this doesn't exist over here, so we don't have to look at that in order for it to have a limit. Since it only exists coming in from the right side, from the positive side, that's the only thing we have to look at. And we can see that there's no jumps or breaks in the graph here as we approach 4 on the y-axis. So yes, the limit actually does exist. The limit is 4. Okay, so as x approaches 1, the limit is 4. So the value is 4, the limit is 4, so that meets this third stipulation here that says the limit and the value have to be the same. Well, they are the same, they're both 4. So there's no discontinuity at 1. Okay, so let's move over into the next interesting point on this graph, which appears to be x equals 2. Now there is a open dot here. I'll try to make that a little bigger so you can see that's an open dot, which means there's a break in the graph there. An open dot on the graph means that there's no actual value of the graph there. Okay, so we definitely have a discontinuity there at x equals 2. So our first one is going to be x equals 2. Okay, what does it fail in order to make it discontinuous? Well, first of all, is it defined? Is it defined in the graph, or is it in the domain of f? Well, it's not in the domain of f. We go over here and we to x equals 2, and we go here, and there's no value there. It's not 5. It'd have to be a solid dot there for it to be 5. So it definitely violates f of 2 equals undefined. Now, does it violate any of the other rules? Does the limit exist at x equals a? Well, in order for the limit to exist, the limit from the left and the limit from the right have to give you the same value. And we can see that they do. We were approaching from the left, and we get a limit of 5, because this graph is approaching 5. It doesn't reach. There's no value there, but the limit actually exists. It's 5. If we approach from the right, we also get the limit of 5. So the limit does exist. But does the limit and the value equal the same thing? Are they the same? Well, no, they are not. So we can say that the limit as x approaches 2 of f of x is not equal to f of 2. Okay, so it fails both of those. Okay, the main one that it violates, though, if you were to, the first one that it violates is this one. This is the main one that it violates. At that point, you don't have to go on and find anything else that it violates. If there's no value there, then it's discontinuous. End of story. Okay, let's move on to the next interesting point, which is x equals 3. Okay, so it looks like if we look at x equals 3, we do have a solid dot here and an open dot here. Okay, so what that means is that there's no value up here at y equals 4. It's not where the value is. The value is actually down here. Okay, so there is a discontinuity here. The graph is headed along here, and then suddenly it just stops, jumps down here, jumps back up here, and then keeps going. Okay, so that's a discontinuity in the graph. So which one does it violate? So I'm running out of room here, so let's go down and let's say here, x equals 3 is our next discontinuity. And it is a discontinuity. Why? Well, number one, is f of a defined? Well, f of a, f of 3. What is the value of f of 3? Well, it's not up here, right? There's a hole. The value is actually here at 2. So f of 3 is equal to 2. That's where the value is. So f of 3 is equal to 2. So that one's good. It has a value. Does the limit exist? Okay, well, as I approach from the left, here it looks like I'm approaching 4 on the y-axis. Okay. As I approach from the right, it looks like I'm also approaching 4. So the limit does exist. They're both sides here, as we get closer and closer to x equals 3, the value becomes y equals 4. So the limit as x approaches 3 is equal to 4. Okay, so the second one passes as well. So we look at the third one. Is the limit as we approach x equals 3 the same as the value at f of 3? Well, we can see these two things are definitely not equal to one another. So it fails the third condition. The third condition that the limit as x approaches 3 of f of x is not equal to the value of f of 3. So that's the one that we would say fails for this test, for this discontinuity. Okay, let's keep going. X equals 4. Okay, it looks like we have a break in the graph here. It's heading along here, and then it's got a value here. That's a solid point, and then it pops up here and keeps going. Okay, so it looks like that's probably discontinuity. Let's see why. So x equals 4 is our next interesting point. Okay, so the first is f of a defined. Well, do we have an f of 4? Well, we go to 4 on the x-axis, and we look for the value. It's here. This is the solid dot. That's the value. So f of 4 is equal to 1. It's not up here because there's an open dot there. That means there's no actual point there. The graph's going to start there, but it doesn't actually have a value at f of 4. Its value is down here. Okay, so f of 4 is equal to 1. Now, does the limit as we approach 4 of f of x, does that exist? Well, let's look at it. As we approach from the left, we're headed down here, What's that approaching? It's approaching 1. Okay, so the limit from the left is equal to 1. Now, as we start on the right side, it looks like the graph is headed here. The limit from the right is actually 3. So the limit does not exist. And if you want more detail, you could say, well, the reason it doesn't exist is that as we approach 4 from the left of f of x, we get, what did we get? 1. And as we approach from the right of f of x, we got 3. So these two things are not equal. That's if you wanted more detail. Okay, moving along to the end of the graph, we have another endpoint. This endpoint is no different from the first endpoint that we had over here at x equals 1. Okay, it's got a solid dot there, so the value exists. It's got a limit from the left. We don't care about the limit from the right because this is an endpoint. So the limit does exist. It's 4. The value is 4. So that's not a discontinuity. Okay, so these are your 3 discontinuities here, and these are the reasons why.